Hi, my name is Alicia Carruthers, and today we're going to be looking at some basics of graphing, including axes, plotting points, and graphing linear equations using t-tables, intercepts, and slope-intercept form. The coordinate plane is made up of two number lines, a vertical number line, which is the x-axis, and a horizontal number line, which is the y-axis. The point at which these two number lines cross is at 0 and is called the origin. Let's look at some other aspects of the coordinate plane. The coordinate plane is divided into four parts called quadrants. The quadrants are counted counterclockwise as follows: 1, 2, 3, and 4. An order pair is made up of an x-coordinate and a y-coordinate. The x-coordinate is always first, and the y-coordinate is second. When x and y are both positive, the point will be in the first quadrant. When x is negative and y is positive, the point will be in the second quadrant. When both x and y are negative, the point will be in the third quadrant. And when x is positive and y is negative, the point will be in the fourth quadrant. Let's look at how to plot points. To plot a point in the coordinate plane, start at 0 and move left or right to the number indicated by the x-coordinate. Then move up or down to the number indicated by the y-coordinate. Plot the point at this spot. For example, if we're plotting the point 3, 2, we would move to the right 3 spaces and up 2 spaces. If we were plotting the point -3, 2, we would again start at 0, move to the left 3 spaces, and up 2 spaces. If we were plotting the point -3, -2, again start at 0, move to the left 3 spaces, and down 2 spaces. And finally, if we're plotting the point 3, -2, again, start at 0, move to the right 3 spaces, and down 2 spaces. You can also use a coordinate plane to graph linear equations. The graph of a linear equation always gives you one of 4 types of lines: horizontal, vertical, rising, or falling. Each line has a number associated with it called the slope. Slope is the steepness of a line. As the line gets steeper, the value of the slope gets higher. When you're given more than one point, it is often helpful to label them. Normally these are labeled as x sub 1, y sub 1, which indicates your first point, and x sub 2, y sub 2. Slope is defined as rise, which is up and down, over run, which is left or right. The rise is the difference in the y-coordinates, or y sub 2 minus y sub 1, and the run is the difference in the x-coordinates, or x sub 2 minus x sub 1. So using that, we can find the slope formula. Since slope again is defined as rise over run, and we know that rise is y sub 2 minus y sub 1, and the run is x sub 2 minus x sub 1. Then the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The direction of the line determines what type of slope it will have. If the line is horizontal, it will have a 0 slope because the rise is always 0. If the line is vertical, the slope will be undefined because the run will always be 0 and division by 0 is undefined. If the line is rising, the slope is positive, and if the line is falling, the slope is negative. Let's look at how to graph some different types of linear equations. We'll look at horizontal and vertical lines first since they are the easiest. A vertical line is a line in the form of x equals a, where a is a real number. For example, the equation x equals 2. No matter what the y value is, x is always 2. If y is 3, x is 2. If y is 1, x is 2. If y is -3, x is 2. If we plot these 3 points, you will see that they give us a vertical line that goes across the x-axis at 2. When you have an equation in the form x equals a number, it will always give you a vertical line. The equation for a horizontal line is y equals b, where b also represents a real number. For example, in the equation y equals -3. No matter what your x-coordinate is, y will always be -3. So if x is 2, y is -3. If x is -1, y is -3. If x is 3, y is -3. If we plot these 3 points, you will see that they give us a horizontal line that crosses the y-axis at -3. Whenever you graph an equation in the form of y equals a number, you will always get a horizontal line. You can also use a t-table to graph linear equations. Let's look at the equation y equals 2x plus 1. If we're given the equation y equals 2x plus 1, the first step is to select 3 x values for our t-table. For this problem, we'll use 0, 1, and -1. We're going to substitute each value for x into the equation to solve for y. So if we substitute 0 into the equation for x, we get y equals 0 plus 1, or y equals 1. So we will put 1 in the table next to 0. If we substitute 1 into the equation for x, we would get y equals 2 plus 1, or 3. And if we substitute -1 into the equation for x, we get y equals -2 plus 1, or -1. You now have 3 points, so we will plot each set of points. The first is 0, 1, so we go over 0 and up 1. Our second point is 1, 3, so we start at 0 again, go over 1 and up 3. And our final point is -1, -1. So we start at 0, we go back 1 and down 1. And we draw a line connecting those points. Another way to graph linear equations in 2 variables is to find the x and y intercepts. An intercept is a point where 2 lines cross, or in this case, where the line crosses the x and y axes. You can see that the x-intercept is at 2, 0 because the line crosses the x-axis at 0. Likewise, the y-intercept is at 0, 3 because the line crosses the y-axis at 3. Notice that when you find the x-intercept, the y-coordinate is 0. And when you find the y-intercept, the x-coordinate is 0. You can use this in an equation to find the x and y intercepts of a line. For example, if we have the equation 3x plus 4y equals 12. To find the x-intercept, let y equal 0. So we have 3x plus 4 times 0 equals 12. If we simplify that equation, we get x equals 4. So we know our x-intercept is 4, 0. To find the y-intercept, we let x equal 0. So we have 3 times 0 plus 4y equals 12. Simplifying that equation, we get y equals 3. So our y-intercept is at 0, 3. We now have 2 points we can use to graph our line. Our first point is 4, 0, so we make a point at 4, 0 in the coordinate plane. Our second point, or the y-intercept, was 0, 3. So we make a point at 0, 3. Then we draw a line connecting the 2 points. A third way to graph linear equations is using slope-intercept form. An equation is written in slope-intercept form when it is in the form y equals mx plus b. M represents the slope, which we discussed earlier, and b represents the y-intercept. If an equation is not in slope-intercept form, to write it in slope-intercept form, simply solve for y, which means to get the y by itself. So in the equation 3x minus 2y equals 4, the first step to get y by itself would be to subtract 3x from both sides. This gives us negative 2y equals negative 3x plus 4. Then we would divide both sides by negative 2 to get the y by itself. So we get y equals 3 over 2x minus 2. From this we can see that our slope is 3 over 2 and our y-intercept is negative 2. We can use these two things to graph the equation. We would start by plotting the point for the y-intercept, which is negative 2. So we will make a point at 0, negative 2. Then remember that slope is rise over run. So you would rise or go up 3 and run or go to the right 2 and plot your second point. Now you can draw a line connecting your 2 points. Today we talked about plotting points, slope, and graphing linear equations in many different forms.